the last thing I want to leave you guys with is that some of the examples that you might get on tests are going to employ the SPSS. I found three videos, three YouTube videos, and actually I might actually post some links to some other videos. Should I go ahead and Laura? Should I go ahead and make you the presenter? Sure. Okay.
Yeah.
Oh yeah, here we go. We're opening 9.5. Every time you click something, it'll be opening now. Okay. Actually, that's an interesting file. Let's leave that open. Okay,
Works for me.
excuse me?
Works for me.
Okay. So let's see what we have here. This is that North Carolina birth data. Okay, and we have, for instance, we have the amount of weight gained during a pregnancy, and we need besides that numerical data. See that in the middle there it says gained. Besides that numerical data, we need a categorical data by two value or binomial categorical data. For instance, marital status. Let's compare marital status to let's try and determine whether being married will make a difference in terms of the amount of weight gained during pregnancy. Okay, so in order to test that, that's an independent samples t-test. Notice that marital status can be 1 and 2, and that the weight gained is a number, right? So if we go into let's go take a look in the variable view. We go down to the bottom or top, either way, click on variable view, and look at that marital status. If we go over to the values on marital status and click into that box, go across on 5 and go all the way, yep, just click into that box. It'll tell us what those values mean. So 1 is married, 2 is not married. So what we're proposing, our null hypothesis is that there's no difference between the weight gained among married pregnant women and not married pregnant women during pregnancy. So let's click OK. And we don't have to go back to the data view if we don't want to. We can just go up to Analyze, and we can say compare means, which is what we're doing here. If we're a single sample t-test, we'd go there. We're going to do an independent sample t-test because it's two groups, two independent groups, married women and unmarried women. So now the test variable, okay, good. In the grouping variable, you're going to put marital status. In the test variable, we want to actually calculate the means of the amount of weight gain for each of those two groups. Now, SPSS needs to know what those values are. In this case, it turned out to be a 1 and a 2. That's why I was interested. I'll make sure that it was not more than those two groups. Okay, we can click continue. Okay, if we go up into options, you can define what your level of certainty is going to be. 95% means an alpha of 0.05. If you wanted your alpha to be 1%, you would change that to 99. But let's leave it 95%. Okay, and let's say okay. Okay, and SPSS produces a table for us. Okay, so now, since it's an independent samples t-test, we get a little bit more data than we would have otherwise. First of all, we can see that the mean weight gained for women married women during pregnancy is 30.56 pounds, and the mean weight gained for women not married was 30.65. So right off the bat, it doesn't seem it's likely we're going to find a difference. But let's go ahead with our t-test. If we go into the second box, there is a group of 4 boxes, F, SIG, and 2 numbers that are on the left-hand side there. If you want to point to the F, where the F is there on that, yeah, those 4 boxes. That is separate from our t-test. That's a test for the equality of the variances. Remember, with independent samples, we needed to know whether or not we could pool the standard deviations. Our rule when we do it mathematically is that one standard deviation is double the other, we would not pool them. If it was not double the other, we would pool them. If we look at the top box, we can see that the standard deviation for married women is 12.8 and for unmarried is 15.2. So our judgment would be to pool the standard deviations since one's not double the other. SPSS made its determination. Okay, so in SPSS, it says, should we assume equal variances? This is an interesting result. Should we assume equal variances? If we look at that on the top line there, that's our null hypothesis for equal variances. So if that number, that F score, and that significance is the p-value. If that p-value is less than 0.05, we reject that null hypothesis and we use the other line. Okay, we use the lower line, equal variance is not assumed. Well, for SPSS, this was a big enough sample for it to say, well, let's not pool the standard deviations. We'll have an advantage if we don't pool the standard deviations. So it's saying you should use the bottom line instead of the top line. If that significance next to the F-score had been 0.05 or bigger, you would have stayed with the top line and assumed equal variances. It actually got a different result than we did. If we just use that kind of simple test of double standard deviations being doubled, it's seeing them as different standard deviations because the sample sizes are so large. It can tell that the variability in the two groups is really different. We wouldn't have been able to tell that just by looking at it, but we're talking about a sample size of 500 and 250. Right, so it was able to determine that easier than we could have. So we're going to use the bottom line. It's really usually not going to make much difference. So our t-score here is 0.063. Clearly, that's not going to be a t-score that's going to allow us to reject the null hypothesis. Our significance is 0.94. That has to be less than 0.05. So in both cases, you can see even if we had assumed equal variances, we would not be rejecting the null hypothesis. Let's do this one more time. Let's pick another couple of variables. Let's go to analyze again. And let's go to compare means. Let's go to independent samples t-test. Okay, and let's go to, let's see, let's get weight out of there. Let's move weight out of there. And let's go to the weight of the fetus or the child, weight of the child. Okay, that's in ounces or grams. I don't think it matters which one we choose. And let's, instead of marital status, let's put in smoking status. Smoke during pregnancy. And again, we're going to define the groups. Yeah, let's roll the dice and say it's 1 and 2. Okay, we should have actually looked it up, but let's give it a try. Let's say, okay, let's see what we get now. Now, in this case, no, we made a mistake. That's probably the label. Let's go back to our data file, our variable view, and look in smoking status. Smoke. Yeah, it's 0 and 1. Okay, so we need to go back and tell it it's 0 and 1. Okay, good. Excellent. Let's do it again. Yep, that's good. Okay, let's see what we get this time. So our means are 117 for women that didn't smoke and 109. That's quite a difference, actually, right? That's in ounces. And our standard deviations look kind of similar, but we're not gonna make that judgment ourselves. We're gonna leave it to SPSS. So if I go down below here, the first thing I try to do is determine which one of these two lines to use, horizontal lines to use or rows to use. Okay, in this case, our null hypothesis equal variance is assumed. Is my significance less than, for the F-score, less than 0.05 so I can reject that? In this case, no. So I'm going to stick with the top line because since that significance is not less than 0.05, I don't have enough evidence to reject that idea and do it with equal variances not assumed. For us mathematically, that would be a different equation we would be using. Pooled standard deviations versus unpooled standard deviations. Okay, so if we go across on the top, we see that our t-score is 3.516, and our significance is, or p-value is 0.000. It's really just less than a tenth of 1%. It's probably 0.00001. It only shows you the three significant digits here. So our p-score is less than 0.05. So if our p-score is less than 0.05, we can reject our null hypothesis. Okay, so that's basically how we would do this in SPSS. Let's just go take one last look at the menus up by Analyze. If I go up to Analyze and I go to Compare Means, let's go to one sample t-test. If we were doing a one sample t-test, all we would have is one test variable that we would put in there, and we would compare, then we would type in the value that we want to compare it to in the box marked test values. So that's really the only difference is you'd put in and you'd get a single box instead of a whole series of, instead of two choices or choices that you had to indicate what each value represented, like 1 and 2 or 0 and 1. So let's cancel that. Let's go back up and let's go to compare means. And let's see, one sample independent, paired samples t-test. Okay. And in paired samples t-test, it wants us to put in two values. We don't have paired samples here, unfortunately. Let me see, marital status. Yeah, we don't have any before and after values here that we can use. But in that case, what we would do is choose one of the values on the left, numerical values on the left, move it into the right box, and then it would wait for us to put in a second value before OK would appear and we would actually do the analysis. And in that case, you'll see that the box that it produces is going to compare the means of the differences between those two variables for each individual person in those two variables, and it's going to compare it to zero and give you a variance and a standard deviation and a t-score, all based on comparing it to zero, just like we used our formulas before. Okay, so like I said, I'm going to post like 3 links to some older YouTube videos that you can take a look at, and so that you'll have some other reference for this, and also see if I have some old YouTube videos that I've done in the past that'll give you some examples of this stuff. Okay, so at any rate, good luck on the test, and